Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay. So this is the lecture number 7 and of electronics, okay, in which I will discuss RC circuit. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details to your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. Okay, so this is RC circuit. I have explained, I have given brief idea about capacitor in my last lecture. You can check it. Okay, so now RC circuit. RC circuit. RC RC circuit. RC circuit. Okay, so this is the RC circuit I'm drawing. Okay. This is the RC circuit, guys. This is the capacitor. This is resistance, and this is plus Q, and this is minus Q. Okay, plus Q and minus Q, and this is the volt, plus and minus. Right. This is the one, and here you can do like this. This is the key. Okay. This is the key. Okay, at t equal to 0. So this is the RC circuit, guys. Meanwhile, just let me check whether I'm audible or not. Then I'll proceed further. This is the key. Okay. Yes, I'm audible. This is the key. So I'll proceed further. Okay, guys. So in this circuit, this is the RC circuit, right? And we can use KVL. Okay. So we can use KVL. Okay. This is the current direction we have taken. Okay. So in loop, using K by KCL, KVL, my apology, KVL. So this is going to be this. Always you need to understand. Okay. This is the direction of current. Direction of current means so a capacitor will start with plus and minus, plus Q and minus Q, right? This is the direction. If direction will be like this, then this will be plus minus, right? So this is plus minus, okay? And this voltage we know already, right? So this is going to be V minus, because this Q, right? Plus minus it is going, so V into, and we know guys here, we know Q equal to CV, guys, right? This very important, you need to note. And then this, from this equation, value of V is going to be Q upon C. Very important, guys. Okay. So here we can write. So this is a capacitor of capacitance. Okay. capacitor of charge Q. Okay, capacitor, okay, RC circuit. So from here this is going to be V, at V voltage is going to be charges Q for this capacitor, so Q upon C, okay, minus IR is going to be equal to 0. So from here we can write CV equal to Q minus IRC equal to 0, right? So from here IRC is going to be equal to CV minus Q, okay, and then we can get the value of I, current. I is going to be CV minus Q upon RC. Okay, this is CV minus Q upon RC. This is the value of I. Okay. Now we know, since I equal to dq upon dt, charge per unit time, right? So I equal to, right? So this is going to be CV upon RC, or we can write dq CV minus Q. Okay, or we can write dq upon CV minus Q equal to dt upon RC, we can write. Okay, and then we can integrate it to charge. So we have given this charge, okay, till q charge is given, so 0 to q. Initially at t equal to 0, q is 0. Okay, so 0 to q. Okay, this one, and this is t is going to be 0 to t. Initially time is 0, and after time t, q charge is given. Okay, this one. Now we'll solve it, simple integration. So this is going to be, this is minus ln CV minus Q, okay, and then limit 0 to Q is going to be equal to minus T upon RC, or just T upon RC, right? Or we can write this integration is 0 to Q, guys, right? Yeah. Or we can write ln CV minus Q, upon CV, that is going to be equal to, because CV is also there, right? We have put the limit, so CV minus Q and minus Q equal to 0. So this is ln CV minus Q equal to Q, ln CV minus Q upon CV is going to be equal to this one, minus T upon RC. What we have done is we have taken minus this side. Okay, so now this value CV minus Q upon CV is going to be e to the power minus T upon RC. Okay, so from here we can write value of qt is going to be CV into 1 minus e to the power minus T upon RC. Very important result, guys. Okay, so qt is going to be, q is charge of T, that is going to be equal to CV into 1 minus e to the power minus T upon RC. Okay, e to the power minus T upon RC. Okay, so this is the very important result of getting charge of the capacitor. Okay, Q, which is function of T equal to CV 1 minus e to the power T upon e to the power T upon e to the power minus T upon RC. Very important result. Okay, and also we can write this we can also write this like q, which is function of t, equal to q0, because cv is constant, okay, 1 minus e to the power minus t upon rc. Both formulas are important, okay. So cv, the qt equal to cv into 1 minus e to the power t minus t upon rc, or qt equal to q0 into 1 minus e to the power minus t upon rc, okay. Well, so this is the q, and from here we can find at t tends to infinity, qt value is going to be, t tends to infinity means here t tends to infinity, this is going to be cv into 1 minus e to the power minus infinity, t is infinity, right, e to the power minus infinity is 0, right. So cv is going to be, of q is going to be equal to cv at t is when t is infinitely large, okay, infinite, okay. And also if, and also here let tau equal to rc, okay, tau equal to rc, tau equal to rc equal to t, okay. So in that case qt is going to be cv into 1 minus e to the power minus 1, okay, because t is this one, t is minus rc will get cancelled, that is e to the power minus 1, or qt is going to be, equal to, if we solve it, so this is going to be, or we can write cv as q0, and this value is 0.63, so this value is going to be 0.63 q0, okay. So q2 value is 0.63 q0, okay. So this is the q value, okay, if rc equal to t. So this is important result, guys. I will draw a graph for it, okay, important graph. These graphs are asked in examinations, okay. Well, so here if suppose if t equal to 5 rc, we can take, if t equal to 5 rc, then in that case q is going to be q0. If you take it, then in that case it is going to be, if you just, we need to put in this equation t equal to rc, 5 rc, okay. So if you do that, then value of q is going to be q0, okay. So this is going to be 0.99 q0, right, or almost, that is almost equal to this means capacitor is almost fully charged, okay, almost fully charged. So capacitor is almost fully charged, q because if t equal to 5 rc, okay. So I'm going to draw a graph, different graphs, okay. Here this is the, I'm going to draw the graph between t and q, okay, between t and q. So we can take like this is tau, okay, and this is q0, and this value is 6.63 q0, okay. This value is 0.63 q0, okay. This value is 0.63 q0, and this value is q0, okay. This is q, this value is q0, and this is 0.63 q0. So in that case this is tau, and this value is going to be tau is rc, okay. The graph is going to be like this one, and okay. graph is going to be like this. Okay, this is the graph between tau is RC. Okay, this one for this equation. Okay, very important equation for charge capacitor Q. Okay, so this is the graph, important graph. Next, if you draw different graphs, I'm going to show you. This one. Okay, so this is T versus Q. Okay, and this is like this. This is 0.63 Q naught, and at this point also 0.63 Q naught, 0.63 Q naught. Okay, so here this is tau 3 or tau 3, this is tau 2, and this is tau 1. Okay, so if we drop the graph, so this graph is going to be like this. Okay, and this graph is going to be like this graph is looking like this, right? Okay, so this type of graph, right? This is the graph. This is at tau 1, this is at tau 2, and this is at tau 3. Okay, so this is T. So here clearly seen, we can see that tau 3, tau 1, that tau 1 is greater than tau 2 is greater than tau 3. Yep, you can see that. Okay, tau 3, okay, in this graph, this one. So this is tau 1 greater than tau 2 greater than tau 3. Tau 1 is greater than tau 2, tau 2 is greater than tau 3. Okay, this is important graph, but Q versus T. Similarly, there is one more graph. This is like this. This is time, and this is Q, charge. Okay, and this is this one. Okay, so this is 0.63 Q naught. Okay, 0.63 Q naught. This is tau 1, this is tau 2, and this is tau 3. Okay, so if we draw the graph from here, this is going to be like this. Second one is going to be like this, and third one is going to be like this. Okay, so this type of graph it will be at T1. This is at tau 1, tau 2, and tau 3. Okay, so this is the 0.3 Q naught. Okay, when tau equal to RC. Okay, so here you can see this is tau 3. Okay, you can see tau 1 is greater than tau 2. My apologies, tau 3 is greater than, in this graph, tau 3 is greater than tau 2, is greater than tau 1. Okay, so these are important graphs. Okay, so tau 3 is greater than tau 2, greater than tau 1, and in this graph tau 1 is greater than tau 2, is greater than tau 3. Okay, well, and also guys, you need to understand here, if R decreases implies tau is will also decrease, means a tau equal to RC, right? So fast charging, this is called fast charging, fast charging. Okay, so now I'm going to solve one question, okay, of RC circuit question. It's a good question, guys. So question is this one. This is the capacitor C. Okay, this is key. This is one, and then there is 20-volt battery. With this, there is this one. Okay, this is the circuit. Okay, this is 5 microfarad, this is 4 ohm, and this is 6 ohm, this is 6 ohm, this is 20 volt. Okay, this is 20 volt. This is the circuit given RC circuit, and what we need to find is, we need to find out Q, charge we need to find Q. So find out Q at C. At capacitor we need to find the charge. Okay, Q at C. This is what we need to find out. Very good question. So how we are going to solve it? So we are going to solve it by Thevenin theorem, which I have already explained in my previous lectures. Okay, you can check it. So first what we are going to do, we'll open this circuit from here, okay, for using Thevenin theorem, and then we'll find V Thevenin, R Thevenin, then we'll make equivalent circuit and add this this capacitor and find the charge. Okay, how we are going to do is, that's what I'm going to explain here. So first we are going to open it. So this is going to be, open circuit is going to be like this. There is one more. This is 10 volt. Okay, this I have forgot to write. So this is 10 volt. Okay, and this is 6 ohm. This is 20 volt. This is 6 ohm. This one we have written here, right? This is 6 ohm. This is 20 volt. This is 10 volt, and this is 6 ohm. This is 4 ohm. Okay, this is 4 ohm. This is 4 ohm. Okay, this one, but this is A and this is B. So we have open circuit here. Okay, for using Thevenin theorem. Okay, now very simple. First step will short circuited the battery for getting R Thevenin, and then for getting V Thevenin, that will use will find the current in this loop, and then will use this KVL in this loop. Okay, so now for R Thevenin, I have already explained it in detail. Okay, that this Thevenin theorem. Okay, so for R Thevenin, we are going to short circuited the battery. Okay, we are going to short circuited the battery. So we are going to short circuit the battery. So we are short circuiting the batteries. Okay, so then this is going to be like this. The battery is short circuited. This is like this, and this is this one. This is 6 ohm. This is also 6 ohm. This is 4 ohm, right? This one. So we have what we have done. We have battery. We short circuited the battery, right? Then this figure will become like this. Okay. Here you can see these two are parallel and this is in series. So R Thevenin is going to be 4 plus these are in parallel means 6 into 6 upon 6 plus 6, right? So this is going to be 4 plus 36 upon 12, right? So this is going to be 7 ohm. So we have got R Thevenin. Very simple, right? Now in this loop, we'll make this circuit again. Okay. So I'm not going to make it. I'll use in this circuit. Right? In this circuit, we can use this one. Okay. So this is the current direction we are taking in this loop. This is loop 1 and this is loop 2. Okay. In loop 1, okay. In loop 1, we are using KVL. Okay. So we are using KVL means this one. 6i minus 20 minus 6i equal to 0. Right. So this is going to be, or this one. Battery direction we have taken wrong. This battery direction is like this, guys. Okay. This is minus and this is plus. Okay. So this is minus and this is plus. Okay. This is the battery, guys. Okay. So this is going to be minus 6i or 20. Just give me 1 second. Excuse me. Okay, guys. Sorry. Next. Okay. So here we are using KVL. Okay. KVL in one loop. Okay. So you can see 20 minus 6i equal to 0. 20 minus 6i equal to 0. So from here 12i is going to be 20 or I is going to be 20 upon 12, that is 5 by 3 volt ampere. Okay, 5 by 3 ampere. This is the current, guys. Now in this loop, because we have to find VThevenin equal to VA minus VB, right? So now we'll find V. So in this loop 2, okay, loop 2, we'll use KVL. So in loop 2, so this is going to be VA, this one, guys, VA minus 4 into 0, there is no current, right? Minus 4 into 0 minus 6i equal to VB. Okay, this VB. So this is going to be VA minus VB, that is V Thevenin. Okay, this is going to be 6i. Okay, and 6i value we know, that is 6 into this 5 by 3, and this is going to be 10 volt. Okay, this is the one. Okay, this is 10 volt, sorry 20 voltage. Any mistake? 6i into 5 by 3. Okay, there is 10 as well, right? There is 10 volt battery as well. This one we forgot to write, so we are using this. So this is minus 10 volt, minus 10. So this is minus 10 is also there. Minus 10 equal to VB. This is going to be plus 10, right? This is going to be 6i plus 10. So 6 into 5 by 3 plus 10, right? That is 20 volt. Now what we are going to do is we'll make a Thevenin equivalent circuit, right? So this is this one battery 20 volt,